I wanted to take a look at multiplication in a few larger bases. So check out this multiplication table. It's humongous, and who can even bear it? It actually goes all the way to 10 in base 16. For my purposes, I only needed to go up through F. F represents the number 15. It's the 15th digit, and it doesn't have the 0, which we don't need. We can do. So let's take a look at what this problem would look like. 8e base 16 times 3b base 16. I forgot to write the teen there, but there it is. So starting off in the ones place, b times e. Totally lost. Have to look and figure that out. So we find b, we find e, where they match up. It's almost dizzying to figure that out. I believe it's b times e is 9a. Who would have known it? So it's a, carry the 9. Wow, I'm carrying a 9. That's going to be challenging. All right, next, b times 8. Again, I have to look that up. B times 8. Let's see, it looks like it's right here as 5, 8, right? B times 8. But remember, I carried a 9, so I have to count up 9 spaces from 5, 8 in base 16. Whoa, let's see if we can do it. All right, 5, 8, and 9 more. All right, let's see. 5, 9, 5a, 5b, 5c, 5d, 5e, 5f. Got to regroup. 6, 0, 6, 1. Challenging to do. 6, 1. So it's put that down. Let's cross out what we carried. Next place value, let's have our space, our placeholder, our 0. So we're now going to do 3 times e. I find that on the chart. 3 times e is 2a. It's a, carry the 2. And then I have 3 times 8. Have to look that up. 3 times 8 is 1, 8. But I carried 2 more. So adding 1, 8 plus 2 in my head, 1, 8, 1, 9, 1a. All right, I have that here. Remember, we're in base 16. Even here, now we have to add these together. A plus 0 is A. A plus 1 more is B. A plus 6, got to think about that. A in my head, doing 6 more. Next one, B, C, D, E, F, and then 1 more, 1, 0. So I have to 0, carry the 1, and 1 plus 1 is 2. That was pretty crazy to multiply in base 16. Certainly not something on the midterm, so don't worry about that. All right, just wanted to show that it could be done. We also, I was going to zoom out and show you something with the Mayan numbers as well. So let me pull in an image from that as well for the Mayan numbers. Now you might remember the Mayan numbers from a previous module. So let's bring this in right now. Okay, there's an image. Let's zoom in and see what we're talking about. All right, so remember, these are the Mayan numbers, 0 through 19. These are the actual digits themselves. But can you imagine multiplying in base 20? All right, now the Mayans had a unique way to multiply, which has actually gotten really famous on the internet as kind of a series of drawing lines. So for this purpose, I'm going to do something fairly small digits so that it's manageable. So if I did something like 2, 1, which, you know, you could also, this by the way works in base 10. You could do it as 21, but I'm going to have it as base 20. So write that 21 or 2, 1, excuse me, times, let's say 3, 2 base 20. Okay, now we can use the standard algorithm and so on, but we need a multiplication chart because we don't know our facts in base 20. So the Mayans had this really unique thing where they would take the first number, 2, 1 in this case, and they would draw 2 lines and that's in the 20s place, and then 1 line in the ones place, and then they would focus on the next number, which is 3, 2, and they would put 3 lines in the 20s place, and then just 2 lines. I need to extend these a little bit here, and then they would just count the intersection points. All right, so what I mean by that is, where do these lines cross each other? Now, the ones to the very furthest right, there's 2 intersection points, so that would be a value of 2. In the middle here, we have 1, 2, 3, 4, 5, 6, 7. That would be a 7. And then lastly, we have 1, 2, 3, 4, 5, 6. Here, 6, So these two go here, and this one goes here. Our number would be 672 base 20. It would also work in base 10 as 672. Kind of cool. You can explore a lot more of that on YouTube if you're interested in that method. I think it's kind of a novelty, but it really doesn't save you any time, and it only is even convenient at all with the lower or smaller digits. I hope you enjoyed this video on multiplication with larger bases.